Welcome everyone. Today we are presenting the 20% milestone for Syntax, a project that blends open world survival with high stakes digital horror. Our goal is to create an experience where the environment is as much of a character as the protagonist herself. The setting is Planet K. Once a digital utopia, it collapsed when the digital vaults designed to preserve the population suffered a catastrophic system failure. Now the planet is a syntax of its former self, filled with corrupted data biomes and entities that view living beings as system errors. We play as Yukin. Sent away as an infant in a modified life pod, she was raised on a distant steampunk planet. This upbringing is crucial. She isn't just a survivor, she's a thinker. She returns to Planet K with the ability to bridge mechanical gears with ancient digital code, which is the only way she can survive the glitches and eventually escape back to her foster home. Now it's time for a quick snippet of our game. As you can see, we have the basic left, right, up, down movements. And we also have three placeholder terrains: agricultural tiles, industrial tiles, and the glitch tiles. The glitch tiles will damage Yukin. If her health falls below zero, she dies, and game is over. She respawns quickly after. As you can see, the terrain is randomly generated into different biomes for demonstration purposes. We only have the three basic tiles, and one that has been implemented is the damaging glitch tiles. Most of what you see right now is still a work in progress, but we will eventually change the textures into something more appealing. Here are future plans we have for our game. First, we have the tile interactions. Industrial tiles and agricultural tiles are tiles you can build objects on. If you build on glitch tiles, there is a chance that the block you place will disappear. There is also a statistics bar that we are planning to add. That the statistics bar will display the following: health, hunger, thirst, sanity, and stamina. Let's talk about each stats. Health. Health is basic hit points. HP can be naturally restored by a hunger. If your hunger is greater than 75%, she will start to passively generate her HP. A lot of things can and will damage Yukin, so maintaining her HP bar is important. Now for hunger. Basic hunger can be resolved by food resources, nodes, items. Naturally, hunger will be reduced when moving around. Thirst is basically the same as hunger, but goes down a lot faster, hence why she carries her own canister, which she can refill by interacting with water resource nodes. Sanity. Sanity gets reduced when getting damaged by glitched terrain, or by encountering hostile entities. Now for stamina. Stamina gets reduced when you're running or when using basic combat. That basic combat hasn't been implemented yet, but we will work on it. Now let's talk about the current codes that we have.
At the core of Planet K is our procedural generation system. Using fast noise light, we move away from static hand-designed maps to a dynamic world which generates a 100 by 100 grid every time the game starts. We use a specific frequency of 0.05 to create a distinct biome cluster, as you can see in the code. The script reads with noise values, which assigns tiles based on those numbers. The map isn't just a background, it's a dataset that tells the player where they are safe and where there are danger. It is very important to note that what you see today is a functional prototype, not the final design. Currently, we are using a limited tile set of copper, grass, and glitch tiles to prove that the biome detection logic works. In the final version of Syntax, the system will be expanded significantly. We plan to include terrain transition, smoother blending between the biomes so that the edges don't look sharp. To ensure a smooth demo, we've implemented a smart spawn system. Since our styles are 64 by 64 pixels, we use a simple calculation to find the exact center of our 1000 tile world. This ensures Yukin never spawns in a glitch zone or off the map. The logic is very vital for the 20% milestone because it proves that we have full control over the player's relationship with the procedural space. By providing this prototype, we've cleared the biggest technical hurdle. Our next step is to dress this logic with more complex art, assets, and specialized in rare biomes that will house the ancient vaults. This prototype is the skeleton. The final design will be the fully released, terrifying surface of the planet K. Thank you.
The setup and safety to bring Yukin to life on Planet K. We develop a script that focuses on modularity and stability. At the top of our script, we use the at export variable for our tile map layer. This is a deliberate design choice. It allows us to link the procedural world to the player directly in the Godot inspector, which fixed the null instance crashes we faced earlier. By using @onReady for the health bar and sprite, we ensure the UI is fully loaded before the script attempts to manipulate it, keeping the game loop clean. Physics and fluid movement. Our movement logic uses input.get_vector. This is much more efficient than four separate if statements, as it handles diagonal movement normalization automatically. We pass this data into move underscore and underscore slide open close parenthesis, which is a built-in Godot function that handles the physics collisions. This allows Yukin to interact with the environment without getting stuck on the edges of our 64 pixel tiles. Our handle underscore animations function then takes that movement data and swaps between her walking and idle states based on her velocity. Environmental sensing, or the syntax logic. The most critical part of our 20% milestone is the check underscore tile underscore damage function. This is how Yukin senses the corrupted world. We use a function called local underscore to underscore map. This is the bridge between our player's pixel position and the grid-based data of planet K. Once we have the coordinate, we check the atlas coordinates. If the code sees that Yukin is standing on vector 2i, open and close parenthesis 5 and 0, which is the specific ID for our pink and black glitch tile, it triggers the damage logic. This effectively turns the environment into a hostile entity. UI feedback and death state. The take underscore damage function manages the communication between the world and the player's HUD. We used a max clamp to ensure her health bar never drops below 0, which keeps the progress bar visually stable. If the health hits 0, the die open and close parenthesis function prints a debug message and reloads the scene. This system reset is our first iteration of the death mechanic, reflecting the lore where the syntax erases and restarts the player's data loop. This script successfully links our procedural biodomes to a playable character, providing a solid foundation for the remaining 80% of our development. That is all. Thank you.
Now let's talk about the technical aspects of our game. The sprite system, directions and states. The 8-way logic, our movement system is built on 8 core animation states that cover both stillness and motion. In every cardinal direction, we categorize these into idle and walk animations for up, down, left, and right. By splitting them this way, we ensure Yukin doesn't just slide across planet K, she actually interacts with the space she's in. The idle states, facing the world. The idle animations, idle down, idle left, idle right, and idle up, are vital for immersion. They use specific frames where Yukin is stationary but facing a certain way. For example, when the player stops moving, the code checks the last input direction and triggers the corresponding idle state so Yukin continues to look towards the last thing she interacted with. The walking states, or dynamic movement. The walk animations, walk down, walk up, walk left, and walk right, are loops of 4 to 6 frames each. Walk down and walk up handle vertical exploration. Walk left and walk right handles horizontal travel across the biomes. These sequences are played at a specific speed, or FPS, within Godot to match the character's physical velocity, making the movement feel grounded on the terrain. For visual cues for gameplay, Having these distinct directions is also a gameplay mechanic for our 20% milestone. This setup allows the player to clearly see which tile Yukine is about to step on, allowing them to react quickly and turn away before her health bar starts draining from a glitch tile. That is all for our video presentation of the 20% development milestone for syntax. As you've seen today, we've successfully established the digital bedrock of Planet Cave. Through our procedural generation and tile detection systems, Yukine is now fully mobile and reactive to her environment, marking the completion of our primary technical foundation. On behalf of the team, we thank you for watching our progress on syntax. We look forward to showing you even further how Yukine will interact with the environment, such as refilling her water canister, the basic combat, some building aspects, and whatnot. That's all. Thank you.